Okay, here you go. So we're going to draw our line down. We're not going to treat this any differently than we do with an equation. We're going to get rid of the smaller variable first. Which one's that?
2x.
And how do I get rid of a 2x? What should I bring down on this left-hand side? -5. I'm happy to hear that. Then I have 2x minus 7. Do you agree? Okay. I want you to try to finish it out from here and graph it. Remember your number line? Open. Is this one going to be an open circle or closed circle?
Closed.
Closed. Why? Because it's equal to. If it has that line underneath of it, it means it's a closed circle. Balance it just like normal. What are you going to get rid of next? What would you get rid of next?
7.
And how would you get rid of it? Very good. Yes. Put them in the student supply area where the scissors go. Okay. I heard we add 7. Add 7. I have 2x equals what? 2. Finally, what should I do? Oh, you're right. I do it all the time. X is greater than or equal to 1. How many checks am I going to have? 2. All right, so on the number 1, should it be an open or closed circle? And my arrow is pointing which way? Right, X is greater than. You always read it from the variable. X is greater than or equal to 1. So we check now. I'm going to check the point first. 2 times 1 minus 5 is greater or less than or equal to 4 times 1 minus 7. I get -3 on that side. Do you guys agree? Okay. And I get -3 on that side. Do you agree? Okay. Now, I have to check the arrow. What number do you want to use?
3.
Okay.
1.
You already did 1. You can do 2. You can do 5.
Oh, we have to do 2 checks.
Okay. 2 times 3. You're amazing.
I tried.
2 times 3 is 6. Minus 5 is 1. Expect lots of emails, Miss Cafton.
Absolutely. If we need to have like a crash course, I'm not opposed to
Works for me. Thank you. Appreciate you. 4 times 3 is 12. Minus 7 is 5. Do you agree with that? Is this a true statement? Is 1 less than or equal to 5? Yeah, so this is true. Okay? Yes. So this is all done now. Okay. Now, I want to talk a little bit about what we learned yesterday with toe the line. What was the only time our paper clips switched spots? Multiplying or dividing by a negative. So anytime, this is really important. So listen to the words that are coming out of my mouth. Anyone know that movie? No? Okay. Shows I'm old. Anytime you multiply or divide by a negative, okay. I know. Okay. Anytime you multiply or add or divide by a negative, your sign has to switch. So if it said greater than, it would switch to less than. If it said less than, it would switch to greater than. That's indicating that's how your paper clips switch spots. Okay? So that's what it's showing right here. If we divide by negative 3 on both sides, do you see right here how our inequality switched positions? Okay? All right, let's go to this last page. I'm going to write this over here so I can work with it. All right, here we go. I am going to. What am I going to get rid of first? How are you going to get rid of a plus 7? Whatever I do to one side, bring down what I didn't use. Do you agree with what I have written so far? Yeah. Okay. Now, what do I need to do to separate that negative 2 and that x? Divide. But I'm going to divide by a... No, so watch what I'm going to do right away. Are you watching? Yeah. What is that? Do you see how I switched the sign? Because I'm dividing by a negative. Yes. Every time you divide by a negative or multiply by a negative.
When we check, is the sign also switched?
No. Good question. I'll show you here in just a minute. So I have x is greater than or equal to negative 6. So I'm going to graph that. Open or closed circle? Closed. Because it said equal to. I want on the numbers greater than negative 6 or less than negative 6. Algebra? Greater. How many checks do I have? I'm going to check the point first. Negative 2 times negative 6 plus 7, and it goes back to its original now. Every time we check, we go back to the original. What's negative 2 times negative 6? Positive 12. And positive 12 plus 7 is 19 less than or equal to 19? Yeah. Okay. Now I need to check the arrow. I'm just going to do times negative 5 plus 7 is less than or equal to 19. Negative 2 times negative 5. What's negative 2 times negative 5? Positive 10 plus 7 And 10 plus 7 is?
17.
Is 17 less than or equal to 19? Yes, so I did it right. So the only thing you have to remember is anytime you do what or what, you have to switch the sign.
So divide by a negative or times a negative?
Yep, multiply or divide by a negative, you have to change that sign. If you add or subtract a negative, do you have to do anything?
No.
No. All right, see that problem at the bottom there? I want you to try it. You are going to be dividing by a negative. How many checks do you have on this one?
2.
2. Open or close circle? Closed. All right, we're going to go over this one, and then we're going to have some nice, healthy, friendly competition.
Oh, gosh.
I love competition.
Can we choose our partners first? You
Mm,
love competition unless you win. Unless you lose. If you lose, you don't like it.
probably. I know. Okay. Let's go over this one, and then we'll get into some competition.
Like, is a competition against partners or competition like partners against
Partners against partners. All right. What did you get rid of first? Minus 15. Minus 15. So you have negative 6 is greater than or equal to negative 3x. I'm going to divide by negative 3. So what do I need to do to that sign? Switch it. X is greater than or equal to 2. Draw my number line. Close circle, and I want all the numbers greater than. I'm going to check my point. 9 is greater than or equal to negative 3 times 2 plus 15. Negative 6 plus 15. 9 is greater than or equal to 9. Does that work?
Yep.
All right.
Do 3.
Arrow.
Do 3.
9 is greater than or equal to negative 3 times 3 plus 15. Negative 3 times 3 is negative 9. Plus 15 is 6. Is that true?
Yeah.
All right. I'm going to stop our recording.